So applying k-mean clustering to customer data. So customer data is valuable resource for business seeking to gain insight into customer behavior and preferences. So with the rapid growth of digital interactions, transaction, the volume of customer data has increased significantly, providing opportunity to understand customer needs. So unsupervised learning techniques, particularly k-means clustering, has proven effective for customer segmentation, allowing business to tailor their products, services to various customer group. So we will explore the practical applications of k-means clustering to customer data in details, and it will provide understanding of theory, implementation, practical insights from k-means clustering. So starting understanding the k-means clustering. So, k-means clustering is an unsupervised machine learning algorithm that groups data point into distinct clusters based on their similarities. So, it aims to minimize the variance within cluster, maximize the variance between clusters by dividing dataset into k non-overlapping subsets. So they're like core concepts like centroid, which is the center of cluster, calculated as the mean of all the data points in that clusters. Then is inertia, that refers to the sum of the square distances between the data points and their respective centroids. And last, convergence. This is the process by which algorithm reaches a stable state where cluster assignments no longer change insignificantly. So, the applications of k-means clustering include customer segmentation, market analysis, document classification, image compressions. And let's do k-means algorithm by step, starting from uh, initialization. So select k random centroids from the data points. Then is assignment step, where we assign each data point into the nearest centroid. And then we update the step by calculate the mean of data points within each cluster to update the centroid. And then we repeat the process by continuing the assignment and update the steps until centroids stabilize, indicating convergence. So mathematically, the objective of k-means can be expressed as minimizing the within the cluster sum of squares. So it is called WCSS, where is the number of the cluster. It also represents the ith cluster and is the centroid of the ith cluster, and it's also a data point within the cluster. So choosing the right number of clusters. So choosing an appropriate value of k is critical to the success of k means algorithm. Several methods can help determine the optimal number of clusters. For if we start from albo method, which involves plotting WCSS against the number of clusters, the point at which WCSS curves start to flatten, resembling an elbow shape, indicating the indicates the ideal number of clusters. Then Silhouette score, which measures the cohesion and separation of clusters. So high Silhouette score indicates well-defined clusters. Then is gap statistic, which compares the WCSS to the original dataset to a randomly generated dataset. Significant gap suggests the chosen number of cluster is appropriate. So, processing customer data for clustering. So we start with the data collection. So collecting comprehensive Customer data is the first step in applying k-means clustering. So relevant data can include demographic information like age, gender, income level, and then is behavioral data like purchase history, browsing patterns, and then it can also be like engagement metrics, which include social media interactions, emails. So data uh, should be collected from multiple sources such as CRM system, e-commerce platforms, customer feedback forms, and then is data cleansing, which is essential to ensure the accuracy and reliability of clustering results. So key tasks include removing duplicate record, eliminating redundant data entries, handling missing values, using amputation techniques to fill values or remove incomplete records. Then is standardizing formats like ensuring consistency in date formats, currency values, categorical variables, and then is feature selections. So selecting the right features for clustering is crucial for meaningful results. So some relevant features for customer segmentation include age that help understand the age distribution of customers, then annual income indicating the spending capacity of customers, then a spending score, a metric to evaluate customer loyalty and engagement. So feature engineering can also involve creating new features by combining existing ones to enhance the clustering process. And then in the last is data normalization. So normalization ensures the features are on similar scale, preventing bias in the clustering process. So common normalization techniques include min-max scaling, scale date to fixed range, usually between 0 and 1. Then is Z-score normalization. So standardize the data by subtracting the mean and dividing by the standard deviation. So normalization is particularly important when feature have different units or the scales. Then applying k-means clustering, we start with setting up the environment. To implement k-means clustering, set up a data analysis environment using Python, necessary libraries. So the required libraries, for example, pandas are for data manipulation, scikit-learn for machine learning algorithm, matplotlib is for the data visualization. So, so we import the libraries and load the data using pandas, and um, then we reprocess the data using scikit-learn, and then we apply the k-means algorithms, and then we visualize the cluster. Then is like interpreting the clustering results. So we analyze the cluster characteristics. So each cluster represent unique customer segment. So examples of possible segments are like cluster 1, high income customers with high spending scores. Cluster 2 is income customers with moderate spending scores. And third is low income customers with low spending scores. Then is like business insights. Using clustering insight can help businesses improve their marketing campaign, personalize campaign based on customer segment, enhance customer retention, identifying at risk customers, boost sales, recommend products tailored to each segment. And however, there are like certain challenges and best practices. So, challenges of like K means clustering is choosing the right K, determine the number of clusters that can be difficult, and there's a certain handling outliers which skew the clustering result. Then is interpreting clusters, which requires domain knowledge of meaningful interpretation. And if we talk about best practices, so we start with the data preparation, which ensures the data is clean and well prepared. And then Then is feature selection, uh, that are that are relevant to clustering task, and iterative refinement, which is experiment with different values of k and clustering method to improve the results. And in the end conclusion, so k clustering uh, to customer data can unlock valuable insight that drive better business decisions. Identifying distinct customer segment can help business optimize marketing effort, improve customer engagement, increase revenue. So these are the best practices addressing challenges, ensure more reliable and actionable results. Thank you.